Hello everyone, today we'll be presenting our topic titled Firefighting Chemistry, Understanding Combustion Reaction. We are from Group 16. This topic explores the science behind combustion and how it applies to firefighting and safety in industrial setting. So, these are our team members, Kenny Ken, Aina Hanisa, Dani Haikar, Radina Humara, and Raudatul Aina. Today, I will be talking about firefighting chemistry and how it's related to occupational safety and health. Firefighting chemistry helps us understand how combustion works when fuel react with oxygen and produce heat and light. While this reaction is useful in industry, uncontrolled fire can be dangerous to people, property, and the environment. In OSH, it's important to know the fire tetrahedron, fuel, heat, oxygen, and change reaction, so we can break the fire cycle using the right method like cooling or smothering. We also need to know the fire class A to K to use the correct extinguisher. So in short, understanding fire chemistry helps us improve safety, prevent fire, and respond better during emergency. We are going to explore some of the most important chemistry principles that help us understand how fire behave and how they can be controlled. Fire isn't just something we see and feel. It is the result of specific chemical reaction. That's why understanding the science behind it is so important, especially in firefighting and fire safety. We will start with the chemical of combustion, how fuel react with oxygen to release energy. We will look at the fire triangle and tetrahedron, which explain what needed to start and maintain the fire. Then, we will talk about oxidation and energy release, and compare complete versus incomplete combustion to understand the dangers of smoke and toxic gas. We will also cover the product of combustion, water and chemical execution. The chemical of combustion. Combustion is the type of exothermic chemical reaction where a fuel reacts with oxygen, releasing heat and light. In the complete combustion reaction, there's enough oxygen for a fuel to burn completely, producing carbon dioxide and water as byproduct. This process is clean and efficient, releasing a large amount of energy. However, if oxygen is limited, incomplete combustion takes place. This creates less energy and produce harmful byproduct like carbon monoxide, a toxic gas, and soot, fine carbon particle. The energy released in combustion comes from forming strong, stable bond in the product. For any fire to occur or continue, three key elements must be present: heat, fuel, and oxygen, often referred to as the fire triangle. The fire triangle and tetrahedron. The fire triangle shows that heat, fuel, and oxygen are essential for fire. Remove anyone, and the fire goes out. The fire tetrahedron at the fourth element, the chemical chain reaction that keeps the fire going. Interrupting this reaction is another way to stop the fire. Oxidation and energy release. Combustion is a fast form of oxidation, where a material reacts with oxygen and release energy. This energy is what causes the heat and flame in the fire. Understanding oxidation helps us know how fire burns and how to stop them. Complete versus incomplete combustion. When there is enough oxygen, combustion is complete, producing carbon dioxide and water efficiently. But if oxygen is limited, incomplete combustion happens. It creates carbon monoxide, a toxic gas, and soot, both of which are dangerous to people and reduce visibility. Then, product of combustion. The product of combustion vary, but usually include carbon dioxide and carbon monoxide, water vapor, and soot. CO is especially dangerous because it's odorless and toxic. Understanding this byproduct is vital for firefighter safety and proper ventilation. The role of water in fire suppression. Water helps fight fire by absorbing heat and lowering the temperature. As it turns to steam, it pushes out oxygen, helping smother the flame. But it's not always safe. Water shouldn't be used on electrical fire or flammable liquid, whereas it can make things worse. Fire extinguisher and chemical suppression. Different extinguisher use different chemistry. CO2 remove oxygen and cool flame. Dry chemicals stop the reaction that keep the fire going. Form from a barrier to block oxygen. Choosing the right extinguisher depends on the type of the fire.
Industrial relevance of chemistry concept in firefighting. Combustion and fire triangle. Combustion is a chemical reaction between fuel and oxygen producing heat. And also, the industrial application for that is combustion and rise help industry manage fire hazard and fire suppression system aim to remove one triangle element using CO2 which is water to remove oxygen. To respond fire suppress, dry chemicals suppressors examples such as monoammonium phosphate in ABC extinguisher interrupts combustion by blocking oxygen and stopping chemical reaction. So the application support affection against fire involving solid, liquid, and electric equipments. Thermochemistry in firefighting. Thermochemistry is a study of heat in chemical reaction. Combustion in extrinsic release heat which is heated and light. So the industrial application is to help predict fire intensity, burn rates, and intonation condition, which also inform firefighting techniques for various materials. Flammability of material. Flammability is how easily a material ignites and burns. So the factor is ignition temperature, physical state, solid, liquid, and gas, chemical structure, and oxygen availability. So the industrial application is guide selection of extinguisher formed for liquid fires, not water. gas laws and fire dynamics. Charles' law is what hot gases expand, which is smoke rises quickly. Second is what Boyle's law. Trap heated gas increase pressure, so the risk of explosion. So the application is about used in ventilation strategies to control fire, spread, and reduce risk in enclosed spaces.
Combustion is at the heart of the firefighting, but it brings numerous occupational safety and health hazards. One of the most serious concerns is exposure to toxic gases like carbon monoxide and hydrogen cyanide, especially when the synthetic material burn. While the SCPA offer protection, any issue can be lead to fatal outcome. Firefighters also face the extreme heat, which can cause the burn and even structure collapse. Chemical hazards vary. Fire involving industrial, chemical, of the electrical sources, and be explosive or corrosive, posing extra danger. Beyond the physical risk, repeated exposure to trauma can lead to mental health issues like PTSD and depression. Carry heavy firefighter gear in unstable environment increases the chance of the physical injury. Therefore, a comprehensive approach is essential, one that combines chemical understanding, proper equipment use, regular training, and mental health support to protect our firefighter on all fronts.
Let's look at a tragic case from Malaysia. The bright sparkler fireworks factory explosion on May 7, 1991. Were improperly mixing fireworks chemicals in a canteen area. A small fire quickly escalated into a massive explosion, killing 26 people, injuring over 100 people, and damaging nearby homes and buildings. The cause was a chain reaction of firework chemicals. Oxidizer like potassium nitrate mixed with fuel such as sulfur and aluminium powder. This material can explode when confined and improperly handled. What's even more dangerous is that some of this metal react violently with water, making standard firefighting methods not just ineffective but hazardous. Firefighters face serious challenges: rapid fire spread, repeated explosions, and a lack of proper training and equipment to deal with chemical-based fire. To prevent such incident, we recommend storing chemicals separately in fire-resistant, ventilated areas, ensuring staff are properly trained, and equipping the facility with dry chemical extinguisher and automatic suppression system. Regular inspection and strict regulatory compliance are also critical for safety. This case highlights the deadly consequences of poor chemical handling and the importance of preparation in high-risk environment like fireworks manufacturing.
In conclusion, understanding the chemistry of combustion represented by the fire tetrahedron is essential for effective firefighting. By disrupting one or more elements of this tetrahedron, fires can be controlled or extinguished. This knowledge directly improves safety by guiding the selection of appropriate fire extinguishing agents such as dry chemicals for flammable liquids or CO2 for electrical fires, reducing exposure to toxic byproducts, and preventing accidents in industrial settings. Ultimately, applying these chemical principles save life, protect property, and ensure firefighters and workplaces are better prepared for fire. Thank you for watching. Bye!